All right, this is section, I don't even remember, 3-2. 3-2. Yes, and there's only 3 examples left on it. So there's a part A and a part B to this section, but it shouldn't take very long because there's only 3 left. So, piecewise functions. You guys got a little taste of piecewise functions in section 3-1. Make it bigger, thank you. We did piecewise functions in section 3-1. And use your pencil. Use your pencil. Not a marker, so if you do colors and stuff, use a pencil because we're going to erase some stuff, all right? So the first thing that we're going to graph is this guy right here, x squared. And it's a parabola. It starts at 0, 0. It goes up to 1, 1. If I plug 2 into this, the x squared, it becomes 4, and then so on and so forth. From there, it goes up to like 3, 9, and blah, 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 all the way up here like this, okay? And it's the same on the other side, right? Now, we only want this parabola, 1, 1, 2, 4. Let me make sure it's, nope, we're not right over here. 1, 1, 2, negative 2, 4. Okay, I'm going to make him nice. There you go, that's what he looks like, okay? Now, we only want that to be the case when it's on the left side of 1, okay? 1 on the x-axis is this guy right here. So basically, there's like an imaginary dotted line straight up and down on 1, and I only want that graph to be drawn when it's to the left or less of that line. Less than that line, to the left side of it. So I'm going to erase everything that is to the right, and where it intersects that 1 at, am I going to put a solid dot or an open dot? Solid, because of this guy right here. He is equal to, so I put a solid dot there. So he just looks like this little parabola. Parabola-y thing here. Okay? And then I have x plus 2 is my next function. And x plus 2 is a linear function. So he starts at 2 and he goes up 1 over 1, up 1 over 1, up 1 over 1. So he basically looks like this. Okay? But again, I have that imaginary dotted line at 1. Okay? And I only want it to be between 1 and 4. So he's not going to go on forever and ever in this direction. He's not going to be an arrow there. He's going to stop at 4 on the x-axis. So if you imagine there's like another chunk or another dotted line at 4, we're only drawing our linear function when it's between those 2 pieces, like this guy right here. This little piece right here. So I'm going to erase this guy. I'm going to erase this guy. And that's what our function looks like. He's going to go on forever this direction. He's going to be dark here. And he's going to go like this. Now, there's one thing I'm forgetting. My dots. Should this be on 1 an open dot or a closed dot? This one should be open. Whenever you have 2 pieces that are right on top of each other like that or whatever, you should have one of them be a closed dot and the other one be an open dot. The problem with having 2 closed dots together is because what if you're trying to insert exactly 1 in there? Then I have 2 different places that 1 could be. And then it's not going to pass the vertical line test anymore, right? Because it'll have 2 x or 2 y coordinates for an x coordinate. So that's not going to work. And this guy over here on 4, should that be open or closed? That one should be closed because it's equal to. So this one's open because it's not equal to, closed because it's equal to. And that's what he will look like. Okay? Happy with that?
Sure.
Sure. Happy as you can be, right? Beautiful, beautiful. Okay. Next. I'm going to draw this one in pencil too. Absolute value function. You should know what an absolute value function looks like. Do you? It looks like a V. It looks like a V. Now, this is how I explain it to my algebra kids because they are learning what absolute value looks like. So watch this. This is kind of a cool explanation. If I strip away the absolute value, I have just y equals x, right? Which is a linear function that looks like, goes through 0, 0, goes up 1 over 1, up 1 over 1, it goes like this. And then it goes down 1 to the left, 1 down, 1 to the left, 1, right? Okay? So, if I strip away the absolute value, he looks like a linear function, right? But, when I put absolute values in something, what does that do? It can't be negative. It has to be positive, right? So this guy is already positive, but how do I make this guy positive? Make him go up. It's like reflecting him across the x-axis, so he's going to go up this direction. These are at complete 45-degree angles, meaning this is like a 90-degree angle in here. You don't have to write that, but I'm just putting that in there. That is at a 90-degree angle unless you stretch or compress him. which is going to look probably like, I don't know, the absolute value of 2x, which is going to make him taller and skinnier, right? But if he's just the absolute value of x, he will be 45-degree angles perfectly. Opposite directions. Beautiful. Okay? Good? Yes? Have we talked about step functions or greatest integer functions yet?
Yeah.
Briefly. Okay. This is what a greatest integer function looks like. I'm just going to go ahead and make a table just to show you the first time, and then you don't have to do this ever again. So, when you have a greatest integer function, it's asking for the greatest integer that is less than your value. Okay? Meaning that you always round down. Always round down. So, the greatest integer of 0 is 0. The greatest integer that's less than 0 is 0. 0 is going to round down to 0. 0.25, which is 1/4, rounds down to 0. 0.5 usually rounds up to 1, but it's going to round down to 0. 0.9 is going to round down to 0 until we get to 1. And 1 is going to round up to 1. And 1.1 rounds down to 1. Okay? And then 1.9 rounds down to 1. I'm running out of pencil here. I got to use marker again. 1.9 rounds down to 1, and it always rounds down to 1. Now, this was confusing the other day because we had a negative number, right? So, like, negative 4.7, I think, is what it was. What is that going to round down to?
4. 5.
Negative 5. I know, as soon as you get negative numbers, it's like crap. Negative 4.5 rounds down to negative 5 because negative 5 is below negative 4. You got that, right? Okay. So, like, think of in negative numbers, not positive numbers, okay? So, there's that. All right, now, visually, this is what this looks like, okay? 0 is at 0. 0.25 is at 0. 0.9, 0.5, they're all at 0 until you get to 1, which is going to be an open circle, and then you're going to bump up to 1. He looks like this. This is a step function. I wish this was spread out a little bit more so you can see this a little easier. Going down this way. Let me finish drawing this and then I can show you. That guy, that's what he looks like. Okay? There is an open circle on the right of every unit and a closed circle on the left of every unit because going along, you're always rounding down until you get to that exact value of the next integer and then you bump up. So that's why there's an open circle on the right side and a closed circle on the left side of each piece. This is like the example that I talked about the other day. What did I relate this to? Do you remember? Age. This is like your age. If you are 16 years old on your birthday, you bump up to 16. And then if you're 16 years old in 3 months, you're still 16. And if you're 16 years old and 11 and a half months, you might say my birthday's in 2 weeks, but you're still 16, right? Okay, so you're going along, and then you bump up. You're going along, and then you bump up. Okay, so there's that. Yes, that's the greatest integer function. And then you can like stretch, compress, move him up, whatever, all that good stuff. But that's what the basic greatest integer function looks like. There you go. Anything else I need to add to that? Okay, we quit.